So guys, as you can see, it displays hello world, and this is a 16x1 LCD, very cheap and easily available. Let me give you a quick go through the code. So this is the code. We initialize the LCD pins here, then we initialize the LCD, then we displayed on the first row, first column hello, the second row that is the 9 to 16 pin world, and then we just cleared the screen and added some delays. So this programming gives us this result over here, hello world. Guys, welcome to learning microcontrollers. In this video I will show you how you can interface a PIC16F877A microcontroller with a 16x1 LCD. This is a 16x1 LCD. It's very cheap and easily available. This do not have a backlight, so it's very good for your budget vision projects. So what we are going to do is that we will program the PIC in such a way that it will display hello world on this LCD. So let's get started. So guys, this over here is the LCD I'm talking about. Very cheap and easily available in the market. Very good option for your low budget projects. It will give you something to see what is going on. So guys, the science behind this LCD is that it have a single row, one row having 16 characters. Like you can display 16 characters in one row, but 1 to 8 and then you have 9 to 16. You first 8 characters, they are like, I am taking them red, the second 8 I am taking as green. Now these are total 16 digits, but they are divided in 2 rows. The first 8 characters, row 1, this is the row 1, 1 to 8. The second 8 characters are the row 2. Now this is basically, it's a single row having 16 digits. But in reality, once you are doing the programming, then in the programming you have to consider the first row, the first 8 characters, the second row, the second 8. So it's a basically 8x2 LCD in terms of programming. So that's how we program it in this way. So guys, let's do the connection. This is our PIC16F877A microcontroller having 40 pins. It's a DIP vision. This is the LCD, 16x1 LCD having no backlight. Then this is the potentiometer we needed to adjust the contrast of the LCD. So first of all, the potentiometer has 3 pins, 1 to 3 mentioned on the body as well. The LCD have 16 pin on this connector. Let's do the connections. You common pin number 1 and 5 of the LCD like this. Then this goes to the pin number 1 of the potentiometer. From there you send it to the common ground of your PIC like this. Now pin number 2 of your LCD will go to the pin number 3 of the potentiometer. From there you send it to the VCC pin of your PIC like this. Now pin number 3 is the contrast adjustment pin. Send it to the adjustable pin of your potentiometer, that is pin 2 in my case. Now pin number 4 is the RS pin. For this you may use any available digital input output pin. I am going to use a pin number D1. For pin number 6, that is the enable pin. Again, I am going to use a pin number D0. Now pin number 7 is the data pin 0, 8 data pin 1, 9 data pin 2, 10 data pin 3. These 4 pins are required in case you go with the 8-bit mode, while we are going to use this LCD in the 4-bit mode. Now for the 4-bit mode, the pin number 14 is the data pin 7. You connect it to any available digital input output pin. I'm going to use a pin number D7. For 13, that is the data pin 7 of the LCD. I'm going to use a pin number D6, that is port D pin 6 of the PIC like this. For pin number 12, it will be the D5. And for pin number 11, that is data pin 4 of my LCD, I'm going to use the port D pin 4, that is D4 of the PIC like this. Now guys, pin number 7, 8, 9, 10, as I told you earlier, are for the 8-bit mode, while we are using the LCD in the 4-bit. Just leave them empty. Pin number 15 and 16 are to power up the backlight LED. This LCD do not have a backlight LED, so do not connect these pins at all. Do not. If you connect them, they will get shorted. So don't just leave them empty. Don't connect even a connector over here. So that's how you do it. So this is the connection here. Now let's get to the hardware before we move on to the programming. So guys, this is the hardware, very simple hardware. We have this LCD over here, the PIC over there, and the small trainer board, and we are using the PIC3 to power up the circuit. So let's get to the programming. Let me open the MikroC for PIC. This is our MikroC for PIC. Let me open the magnifier so we can zoom in. So guys, on the PIC, you go to the file, new project. This window pops up, click on next, write the name of the project. I write 16 /1 LCD tutorial by LM. Okay, this is the name I wrote. This is the path your files will be created. Select the microcontroller. I'm going to use a PIC16F877A. The crystal I have at pin number 13 and 14 is 16 megahertz. So I write 16 here. Click on Okay, there is a problem. We gave some special characters. Okay, I remove these slashes, they are causing problem. Okay, click on next. Okay, this was a problem. I accidentally wrote this, so it should be LCD like this. Okay, you cannot start with the number, so I write it LCD here as well. So any name will do, but do not start with the number. Next and finish. So this window pops up. Press Ctrl S to save your work. Okay, like this. Now guys, go to the right. Micro libraries expanded to system libraries expanded. There you have the LCD, this one, check mark this, expanded. There you have this command called LCD-INIT, double click on it. This window pops up. There you have these commands, copy them till here. Now go back, paste it above the void main like this, and here you define the pins that you are using. For the RS we are using pin number D1. For the EN we are using D0. For D7 we are using port D, pin 7. For data pin 6 we are using D6. For data pin 5 we are using port D, pin 5, D5. For data pin 4 it's D4. Now this was the pin setting. Now this is the pin direction. Do the same. For RS it's D1. For EN it's D0. For data pin 7 just happened, I pressed some button accidentally. Oh, I pressed I think F12. I pressed F12 accidentally, sorry. So go down. So for data pin 7 it's D7. Data pin 6 it's D6. Data pin 5 it's D5. For data pin 4 it's D4 like this. Now go to the right again in the LCD-INIT, double click on it. This window pops up. Go down. In the example, there you have this command LCD-INIT, paste it in the one-time loop like this. Give some initialization delay, not necessary, but I always suggest you give it in the one-time loop. Now the LCD is initialized. Go to the forever loop, write while 1. Forever loop starts here, ends here, and inside the forever loop, go to the right. There you have this command LCD out, double click on it. This command over here, you copy it, you paste it here, and this is the first row. Now as I told you in the presentation, the first row have total of 8 characters. So we display hello here, and in the second row I display world. So this will be second row, like it will be the 9th character, 9, 10, 11 up to 16, and we display here world like this. And then to make it look better, we will keep displaying this for like 2000 milliseconds, and hello will be displayed first, and after that there will be a pause just for adding beauty, and then this will be displayed there, and after that it will clear the screen. That will also just I am programming it that way just to make it look like we have control over it. So we will clear the screen, and screen will remain cleared for like, so it should like it be a blinking effect 200 milliseconds. So that's it. I built this code, built, no error. Now we go to the PIC16 programmer tool, this. Now click on the PIC16F877A, the microcontroller you're going to use. This one, go to the file, import hex file. This is the file we just created. Double click, click on write. Okay, the new file is being written. You have to wait. Go to the hardware. This is the hardware. Okay, wait for the file to be written. Okay, it's done. Power up the circuit using a PIC3. Okay, see the hello world. Hello world. So see, it is working. This LCD is very cheap and easily available. It can be used in tons of projects. So guys, this is it. I hope you guys learned something from this video. If you guys have any questions, you may ask. So we'll see you in the next lecture. So goodbye until then.